Before we dive in, we're going to actually ask Todd Zabelle of Project Production Institute to give us some framework on how to think about what's to come. Todd is the founder and president of Strategic Project Solutions, as well as the founder of Project Production Institute. Prior to founding SPS, Todd founded Pacific Contracting. Established in 1993, Pacific Contracting was recognized in the mid-90s for its use of a variety of innovations, including lean construction, virtual design, and construction. In July 1998, these efforts were acknowledged in the UK government report of Rethinking Construction. Over the past 2 decades, Todd has authored numerous papers on the topics of optimizing engineering, fabrication, and construction. These papers have been published in various technical journals, presented at numerous conferences around the world, and cited by several authors. Over to you, Todd.
Thanks, James, and welcome everyone to what is going to be, I believe, well, it's already started off as a very exciting day or evening, depending on where you are in the world. As James said, a little bit of context as to what we might want to be thinking about when it comes to digitalization in construction. From PPI's perspective, we think there's probably 3 big things that are going on. Let's start off with on the first part here is more on the physical side, where we see robotic and additive type manufacturing becoming more prevalent within the production system for capital projects in construction. Obviously, autonomous vehicles are going to play a significant role. We are seeing autonomous now get into site grading and mining type operations. There are people that are looking at using autonomous trucks to move materials and equipment around, and that all seems very exciting. And finally, the thread that all puts it together is digital. And to delve a little bit more into digital, a good friend of mine who spoke at PPI a couple years ago, Sanjay Jha, he was head of Motorola Mobility prior to selling that to Google, said, look, there's not a lot of new stuff really going on here. What we're really experiencing is a confluence of technologies coming together that are going to allow us to do things we couldn't do before. And he said, 30 or 40 years ago, I got my PhD in AI and ML. He said, but what's happening now, again, as I just said, is the confluence. So what is the confluence? All right, we're starting to see incredibly faster networks, especially with the rollout of 5G, creating its own massive capital investment, extremely fast computing power, and the hope for what might be possible with quantum. James and I actually attended a conference last year where the computational power of quantum computing is nothing short of amazing, and is a game changer if we're able to bring that to fruition, or we should say people like IBM. And finally, what we have now are these massive data complexes in the form of data centers and distributed data management that didn't exist before. So the reality of the situation is we're able to move massive amounts of data and process them at incredible speeds, right? And so the question might be, what do we go do with all this? And clearly, this is resulting in new business models and strategies. It's interesting to see how some engineering and construction companies, to keep within our industry, have now decided that they are moving more to providing digital solutions for their customers. And there's a lot going on there with what might happen with business models. The 3D models, 4D visualizations, any type of data it's its own potential revenue source and value source for those that might own it. There's numerous startups, always very intrigued by people starting up new organizations and new enterprises to go do new things. but not all those things are always new. And finally, every company that's worth their salt wants to be a digital enterprise, and that should not be surprising when we think about it. The valuation and share price of companies like Microsoft, Google, Amazon, Apple, and so on and so forth become very enticing to people that might be in more mundane businesses. If you watch CNBC at any time, there's lots of debate on, is Tesla an automotive manufacturer or a tech company? Their valuation is clearly as a tech company. So as these new business models come together, these new technologies come to market, and we're able to do capture and have access to more data, who will own the data and what will they do with it is a very interesting question. It's not necessarily the question that we're going to answer today, but if I'm an owner, or if I'm a contractor, or if I'm a software provider, and having been all three of those through my career, that is an interesting question. Whose data is that? There is some precedents where people have argued that the engineering on drawings are owned by the engineering company or the architectural company. But this is a big question and is going to cause a lot of consternation in the future. I think the big question today really though is, so mass amounts of data are being processed, moved around, and stored all over. How can and will construction benefit? What can we do with additive and robotic manufacturing, or what we might want to call more industrialized production? And what can we do with autonomous vehicles? And again, what do we do with all the data? Three big things that we know are happening in construction is this dawning of automated data transfer, IoT sensors, and we're going to hear a bunch about that today. A lot of information moving back and forth. People talk about data capture. I think if you're chasing data capture, you're probably not, you're missing the point. It's really data transfer, or transceiving, if you will, in the form of radio speak. There is data science. Now that we have mass amounts of data, what do we do with it? AI, ML, RPA, and then finally, there's a lot going on with simulation and visualization. And I think that's what James said that the survey or the poll had told us. All right. One of the questions that we think about a lot at PPI is, do we really need to visualize things that might actually be able to become automated at some point? And so that's a question in itself. So how do these things interconnect? Might be another thing to ponder. But I start with a quote from Peter Drucker. There's nothing so useless as doing efficiently that which should not be done at all. And so we find a lot of people with new technology that are out there to go do interesting things, but as Dr. Fisher would say, perhaps not so interesting. All right. And so the question becomes, are we planning to take all this capability that's been bestowed upon us? And I think it's important to realize the engineering and construction industry plays a role in all this. We're going to build the infrastructure, whether it's the 5G network or 6G, whatever's coming down the pike in the future. We're going to build the data centers. We're going to build the cooling systems and so on and so forth that allow all this to happen. But we're going to build it for people that are going to build the capabilities anyways. Our job isn't to go figure out whether we should build a 5G network or not, or create a faster processor. Our job is to figure out how to leverage that stuff. And so part of what we've done today in the panel, as you'll see, is we have people that are from a cross-section of industries that are doing interesting things to actually show us where all this is headed, because we need to decide what might we go do with it. Again, back to that construction, is how can engineering construction benefit? Okay. But ask this question: automate, optimize, or innovate, because what do we go do with this? This is really, I believe, important. Should we automate the current process? Clearly, the more you move to innovate, the higher the value. So is your strategy to optimize Is it to automate, optimize, or innovate? And we believe that, of course, the highest value is through innovation, and that these tools and capabilities technologies are going to allow us to do things that we don't even know that we could do yet. All right. And so if we are going to just stay in the world of automation, where a lot of people are, and I got to say, if you want to do a startup and you want a high valuation and you really want to, as Roberto Arburlo would say, take the attention of people in the investment community, believe it or not, they're not really interested in blue ocean innovation. They get very excited about automation. And so one of the challenges I believe that's going to occur here is when you talk to the people that invest in technology, they would like to know, how many users do you have? How many users can you get? And we really don't care if you're making money or not. That's not important to us. It's just really, how many customers do you have, right? And so they prefer things that could have a very high customer base, a very large customer base, and a limited amount of innovation when they can select automation. And I find that very interesting and very profound, because you would think, and sitting here literally in the middle of Silicon Valley where I live, you would think that these guys would be about innovation. But the investment community has somewhat changed a little bit and is looking to automate current process. And maybe that gives you some insight as to why some of the software deals for construction have gone the way they've gone, and why companies like Procore have a $5 billion valuation, because they're automating something that people seem to value. So what could or should be automated is a question. If we're going to talk about automation, do we need to automate project management functions? So if we look at project management as defined by the Project Management Institute, and we look at things such as scheduling, organization, procurement, are these things that we really want to go automate, or should we look at this from a different perspective? And clearly, and I think this goes back to what Anil Seth was talking about earlier, the idea of mental models being at play, and those mental models drive business models. So there's a lot at risk for people and what it is they might go do. And there's lack of what I would suggest to you as a framework to properly understand how you might go optimize things or even innovate, if you will. I'll give you for instance, we were observing a situation where someone is using machine learning to optimize drill rig movements. And so, as you may or may not know, in energy field development, drilling is a key element, and it's very expensive to move a drill rig. Some drill rigs might have 100 trailers worth of what they call the spread that goes with it, and you want to get that right. And so if you take all of this information that's telling you how your reservoir is performing, you want to figure out how best to move your drill rigs around based on a variety of issues, including potential revenue through production, cash flow, cost, utilization, so on and so forth. Okay. And so someone decided, why don't we use some ML to figure out how to optimize the drill rig movements? And they did it, and they did an excellent job in doing it. However, because they didn't understand the fundamental operation science aspects of what they were doing, the drilling was optimized, the work in process exploded, cycle time got extended, and a lot of cash was used, and a lot of cost was increased because of that. And so I think we need to use these tools wisely and be aware of what it is that we're actually trying to accomplish. And so we propose that what we might see out there is a lot of well-intended actions resulting in unintended consequences. Again, we're not saying this is bad, but we're saying you got to understand what it is that you're trying to do. In another instance, we know that $100 million was invested in a machine learning exercise and data science exercise to understand what might be going on. And the person that invested the 100 million, or the company, said, what'd you find? And the data science people said, well, we didn't find anything. What is it we were looking for? And so you got to be clear on your objectives as to what it is you might be trying to accomplish. We're going to propose and this is why we're PPI, is that the production management provides the framework to leverage this new technology. And when you step back and you think about it, it's kind of obvious. Whether you're dealing with IoT sensors that you're going to hear about shortly and other types of data transfer, including connection with GPS, GIS, and you might be thinking of flight tracker, DHL's or FedEx's tracking information. We're very excited to have Ryder here with us today and what they're doing. If you think about the use of RFID, we know that tools, hand tools even, are getting instrumented. We've had some discussions with Stanley Black & Decker, on-site robotic type equipment. Hilti has an interesting piece of equipment they've just rolled out. All that stuff is about doing work. And the people that are investing in what I would call advanced technologies are really around how do we do work better. I think the work is more work around what we'd call the production work, and we'll see that later when we look at what's happening in automotive and other sectors in the later session. I'm going to propose to you that really what we need to be thinking about is 4 verbs, 5 levers, and 3 curves. All right, I'll explain in a sec, but if you can get your head around 4, 5, 3, this might give you a different perspective on how you might invest and deploy technology. The first thing is we need to somehow get focused on what it is that we do. And what we do as the engineering and construction industry is we design, make, transport, and build stuff. All right. And when you start to move away from these verbs, you get off into all sorts of functional activities that people enjoy playing around with, but it's not really where the value is created. As a matter of fact, the people in the lean community would say that these are the value-added activities or the core process. So we can include in design a definition, scoping, opportunity shaping, detailed engineering down to the threads on the bolts and everything in between. Make, we're talking about whether it's high volume manufacture or low volume fabrication. We need to make things, we need to move these things around, hopefully as little as possible, though some believe otherwise, surprisingly. And we need to be smart and intelligent about our transportation, how we look at that. And then we need to build these things on site, and under building, we're talking about commissioning and startup as well, and handover. But these are the big 4 verbs, and how we design, make, transport, and build is really going to influence what the return on investment is. PPI has also been very pushing very hard, if you will, for what we believe to be the framework to understand and influence production systems, and that is the cost, time, and cash you use to go build an asset, or for that matter, build anything, is a function of how you design the product. The product could be something like a nut or a washer. It could be a complete data center, hospital, LNG facility, whatever you may. What work processes, the transformational work that you do to create that product, the interrelationship between the product design and the process design, and then finally, what we'd call the operation science aspect of this is how you allocate capacity, and think about the contributors of capacity being labor, equipment, and space. How you manage inventory. Think about inventory as inbound and outbound stocks. Inbound stocks is stuff in the form of raw materials, outbound stocks in the form of finished goods, and then think of WIP, or work in process, not progress, process, which is anything that's not shipped out to the customer that perhaps from their perspective they're actually using. And then finally, there's variability, which is anything that isn't the way it should or you want it to be. And the interrelationship between these 5 levers. There's no free move on the board. You can't just go change the product design and not have implication for the other 4 levers. You can't induce variability and not have a loss of capacity, growth of inventory, or some combination of both, right? We've talked a little bit about how do we predict things, and this is well known in manufacturing that prediction is usually around the amount of inventory, specifically WIP, that you might have as to how long things might take. And so there's a relationship between inventory and time. And as Dr. Spearman Sr. would say, inventory is the proxy for time. Finally, there's three curves. We're not going to get too far into this, but there's a complete lack of alignment and understanding of some fundamental things. And if there's anything we really could get across today, and I understand this is the digital part, but is that there are four verbs that we're working on. There's 5 levers to influence it, and then these curves. And the curves say, if you drive up utilization of some kind of a process or system, cycle time or schedule duration in the form of a project will take longer, it'll get extended. And that should be well understood. If you're traveling from point A to point B in your car and there's traffic, then it's going, and so in traffic would mean high utilization, it would take longer than if there wasn't, all right? And the more variability that you put into that utilization, the worse it's going to get, okay? The amount of throughput or work we get through a process, a system, that could be knowledge work in engineering or in opportunity shaping, or it could be physical work in a fabrication shop or on site, is a function of how much WIP you have in the system. And at some point, it doesn't really matter how much more WIP you put into the system, you're not going to go any faster, okay? What you might do is tie up a bunch of cash, and perhaps, as the far right curve tells you, you might make things last a lot or take a lot longer than they should, okay? So really what we want to frame the data around, and James talked a little bit about this, is what we believe at PPI to be something called intelligent production. And we believe that we're at the dawning of production systems where there's supply chains that feed construction, or whether they're fabrication shops, or we could even start getting into healthcare, emergency rooms, automotive manufacturing plants, whatever the case may be. We believe that production systems in the not too distant future will self-organize, and they'll optimize using operation science supported by digital technology, right? And as this session goes on, what we want you to think about, if you will, is as everything becomes connected, right? If we look at this, here's the world we live in with process flow diagrams flowing from left to right. In this particular instance, we're saying that there perhaps is some raw materials of pipe that somehow is going to come out the other end into something on site. All sorts of mechanized and digital equipment does certain operations to it, whether it's trucks moving things around, robots doing work, welders perhaps doing work, forklifts moving things around within a warehouse. All of this is going to become connected very soon. Again, the engineering and construction industry is not driving this. I don't know if Miller and Lincoln have taken and announced digital welders, but I'm sure it's just a matter of time before there's sensors built into those that are going to do all sorts of stuff. Guys that are out there trying to track and trace things, I think through manual means are going to be long gone in the next couple of years. All right. And with that, I will hand it back to James Chu.